Hello and welcome to calculating derivatives of inverses. So, to begin with, let's talk about calculating the inverse of a function, as well as let's talk about how a linear function, the inverse of it, and its derivative compare. Throughout this presentation, you are encouraged to attempt the problems prior to continuing and listening and watching their solutions. So, first of all, calculating the inverse of a function, the first step is to rewrite f of x as y, and then for an inverse, we switch x and y. So to calculate the inverse, we're going to switch it from being y equals 4x minus 5 in its original form to x equals 4y minus 5. We are then going to solve for y. So the first step is to add 5 to both sides, then we divide by 4. Giving us the equation for the inverse being x plus 5 over 4, and the notation that we use is f with the superscript -1 of x is equal to x plus 5 over 4. Next, we want to compare the derivative of this inverse with the derivative of the inverse function. So first of all, in calculating the derivative of the inverse, we want to distribute the 4 in the denominator. So this gives us f inverse of x is equal to x over 4 plus 5 over 4, which is equivalent to 1/4 x plus 1.25. Then, calculating the derivative of this, derivative of 1/4 x is 1/4, and the derivative of 1.25, being that it's just a number, is 0, giving us the derivative of the inverse is equal to 1/4. Now, if we compare that to the derivative of the function, the derivative of 4x minus 5 is just 4, which is the same as 4 over 1. The key idea here is that the derivative of the inverse and the derivative of the function are reciprocals, meaning if given a single point corresponding to the inverse of the function, to get from the derivative of the function to the derivative of the inverse, all we do is we just flip it, meaning it's the reciprocal. Slide we have a quick definition of this, and that is if the function is differentiable, meaning the derivative exists, and the derivative of function is not 0, then we can calculate the derivative of the inverse, and the derivative of the inverse will be the reciprocal, meaning flip the fraction of the derivative of the function at a corresponding point. And as a reminder, between the function and the inverse, we switch x and y, so that corresponding point, the y value for the function will be the x value of the inverse. So a formula for this is given below, where f inverse prime at a is equal to 1 over f prime of f inverse of a, with the inside part corresponding to that x and y are switched. So let's go through an example of calculating the derivative of the inverse at a particular value. So in this case, we want to find the derivative of the inverse at x equals 17. Now, when the inverse of a function has 17 as an input, that means the function itself has 17 of an output. So using the reciprocal rule for the derivative of the inverses, we need to find the x value of the function when 17 is the output. This results in the equation 17 is equal to 3x cubed minus 7. Solving this means adding 7 to both sides, dividing by 3, and then cube rooting, which results in a corresponding x value for the function of 2 when the input to the inverse is 17. So 2 and 17 corresponds. So f of 2 equals 17 means that f inverse of 17 is equal to 2, and we will be using this to calculate the derivative of the inverse when x equals 17. So now, the formula for the derivative of the inverse at 17 is 1 divided by the derivative of the function of f inverse of 17. Or in other words, the derivative of the inverse at x equals 17 is 1 over f prime of 2. So in this case, f prime is 9x squared, and we can plug 2 into that to get 36. So the derivative of the inverse of 17 is 1 over 36, and that is our answer. Below are some practice problems. You are encouraged to do these and check your solutions against the work shown. Thank you for watching. I hope you learned something from this. If you have any questions, you are welcome to email me. Have a good day.